Weight is what we generally refer to as the force that the Earth exerts on an object. When we talk about gravitation later on, we'll get into a more specific definition of weight. But for now, let's say that it is the force that just the Earth exerts on an object. The reality is that weight is different on the moon than it is on Earth, different on other planets, but we'll just focus on the Earth right now. So let's say we have the Earth here, and we have some object above it here. And then we have the object's weight as the force that the Earth exerts on this object. Okay, so the force of the Earth on the mass here, and we know that a force, a net force, is equal to a mass times an acceleration. And so then therefore, since weight is equal to is a force, we have our weight is also a mass times an acceleration. And if we assume that the only force, so the sum of all our forces, is just the weight, so the only force acting on the object was the force due to the Earth on the object, is if we assume the only force acting on it is the Earth, then we know from our assumptions of free fall that the acceleration here is equal to 9.8 meters per second squared downwards, right? Which we said was equal to g, right? So weight is the mass of an object times the gravitational acceleration. So we have a force as equal to a mass times a specific acceleration here, right? So the definition of weight, and like I said, we'll define this more specifically later on, but weight is simply an object's mass times the acceleration due to gravity. From here on out, I will stop writing W as weight because we'll introduce this variable. We'll introduce other W's later on. So I will just write mg as the weight. So let's say we have a box on a surface. The forces which act on it are mg and a normal force. And so this is our weight.